Welcome to this session. This session is solve the second example on how to solve forces acting on a particle. So the problem says, three forces act upon particle as shown below. Given that the particle is at equilibrium, calculate the value of the angle theta and the value of the force P. So for us to solve this problem, we need to resolve the forces acting on this particle by drawing right angle triangle to this diagram, and then using trigonometry to resolve the components. So this is the direction, this is the vertical direction, this is the horizontal direction, this is the vertical direction, this is horizontal, this is vertical. So on this diagram, you see that this is adjacent. So because this length of this force, which form the hypotenuse of this right angle triangle, is 140, so this will be 140 cosine of 45 degrees. And then here, this is vertical, so it will be 140 sine of 45 degrees. This one will be 100 sine of 30 degrees. And then this horizontal, for this length here, will be 100 cosine of 30 degrees. While this one here will be, this with respect to this triangle will have, this opposites will have P sine of theta, and then this will be cos P cosine of theta, this length up to this point here. So therefore, we resolve both horizontal and vertical. So remember, by definition, for system, according to Newton's second law of motion, net force is given by mass times acceleration. And then since the particle is at equilibrium, then acceleration is 0. So which means that net force acting on this object, so mass times acceleration, mass times 0 will give us 0 vector, just 0. So let's resolve the net force in the x direction. Will give us, so we take going to the right as positive, going to the left as negative, going down as negative, going up as positive. So this one going, this is going to the right, so we'll have P cosine of theta is positive, plus this is also going to the right, 100 cosine of 30 degrees, but this is to the left, so negative 140 cosine of 45 degrees should give us 0 value. And then for vertical direction, net force in the vertical direction is 0. So we'll have, this one will be 100 sine of 30 degrees. This is also going up, positive 140 sine 45 degrees. But this one is going in the downward direction, so to be negative. So minus P sine of theta should give us 0. So call this equation 1, call this one equation 2. So from equation 1, you see that P cos theta is the same as 140 cosine of 45 degrees minus 100 cosine of 30 degrees. This from 1. And then from 2, we have P sine theta is given by, so taking this one to the right, so we'll have 140 sine 45 degrees minus or plus 100 sine of 30 degrees. Call this one equation 3, call this one equation 4. So if I say equation 3 divided by equation 4, then I'll have this side will give me, or I say equation 4 divided by equation 3, I'll have sine of theta over cosine of theta, which is just tan theta, is the same as 140 sine 45 degrees plus 100 sine 30 degrees divided by 140 cosine of 45 degrees minus 100 cosine of 30 degrees. So 140 sine 45 plus 100 sine 30, and then I'll get tan of theta is equals to 50 plus 70.2 divided by 140 cosine of 45 minus 100 cosine of 30 degrees. I get negative 50 root 3 plus 70 root 2. So 50 plus 70 root 2 divided by answer, I get 12.02308,199. So which means to get theta alone, I'll get tan inverse of that answer, 12.02308,199. Tan inverse of that answer is 85.24546,162 degrees, roughly 85.23 degrees to nearest 4 significant figures. So that's what theta is. And then, so to get the value of P, we use one of the equations. We have one of the equations. So from equation 1, P will be given by, so I'll have 140 cos 45 minus 100 cos 30 and because this was, I need to divide through by cosine of theta, This is 30 degrees north theta. So this is 30. So cosine of the angle theta here is 85.23 degrees. So when you work out this, 140 cosine of 45 minus 100 cosine of 30 divided by cosine of 85.23. So I get 149. P will be 149.0259108 newtons. So that is what we get as our solution for that given problem. Thank you.